I think you were like, wait, did I start the video? Today, there was a slight pause, just as a little surprise, okay? I know you were expecting me right away. Now, we're going to start a new unit, and this unit is kind of fun. It's going to be fun. I promise you it's fun. It's fun because anybody could do it. If you have mathematical, logical reasoning and logical sense and common sense and good pattern recognition, okay? So let's get started. Binomial theorem. Why are we starting with 9.2? You'll understand why, okay? I think it's more familiar to you, so I wanted to get this out of the way before we start the fun stuff, okay? The binomial theorem also has a lot of pattern recognition. I hope you're good at that. What is a binomial theorem? Perhaps you've seen it before. Perhaps you already know it. Okay, let's see. Now, this here, do you see any pattern? But if you don't, it's okay. Let's go here first. Now, if you saw this pattern right now, would you be able to write the next 3 rows, 4 rows, 5 rows, and so forth? Okay? Excuse me. Okay, so you're done. While I was sneezing, you probably wrote the next 2 rows, maybe, if you see the pattern, okay? Maybe you don't, I don't know, okay? Why don't you stop the video and write down every pattern that you notice. Just write it down on your own paper, and then also write the next 3 rows for me. Ooh. Maybe you know the name of this guy. This guy is called a Pascal's triangle, okay? Yeah, if you know and if you heard of it, that's great, okay? Go ahead and write all the patterns that you notice, okay? All right, welcome back. Did you notice that this is row 1, 2, 3, 4, 5, 6, and so forth? Okay, maybe you also noticed that the edges are always 1s. So you can predict that the edges will continue to be 1. And this goes on forever, infinitely. Okay, maybe you noticed that. And did you notice how we were able to obtain this 2? Or maybe this 3? Maybe this 4, this 6, this 4, 5, 10, 10, 5. Did you notice any of that? Okay, maybe you did, maybe you didn't. If you didn't catch it this time, don't worry. Your pattern recognition will definitely improve this unit, okay? Did you think that this was a 6, 15, 20? Maybe 20 you thought? Because you'd be right if you did. 15, 6. And if you didn't see it this time, it's okay. Maybe now you see it. You're like, oh yeah, this could be a 7, a 21, 35, 35, a 21, a 7. Maybe you're like, this is an 8, this is a 29. Oh my God, this is a 56, this is a 70, this is a 56, this is a 28. And maybe you're a little bit worried. You're like, do I have to, wait a second. Sorry guys, sorry, I made a mistake here. You're like, what? 29, sorry, 28. You're like, do I have to memorize this? Of course not. If there's a pattern to something, you don't have to memorize any of it, right? There's a pattern. So you can always derive this if you needed it. Okay, that's a pattern that maybe you noticed. So writing the next 3 rows would have been pretty easy to do. Did you notice anything else? This is row, well, let's see. How are you achieving these values, right? That's another important thing. Okay, also this is row 1. This is row 2. This is row 3, right? And you're like, wait, this is row 3, but it says 3 here. This is row 2, but it says 1 here. This is row 4, but it says 4 here. Oh, how does that make you feel? Maybe you're like, wait, every row that I'm at, the number that I'm talking about, the row, is actually, this is row 2, it's here. This is row 4, right? And there's a 4 here, but a 3 here. So maybe you're noticing something like, wait, maybe this means row. This means this is row what, right? Because the 2's here, right? Okay, so this is weird. This can't be row 1, 2, 3, right? This is row 1, row 1, row 2, row 3, row, oh, sorry, 2. I keep skipping the 2, right? Row 2, row 3, row 4, row 5, and this only makes sense if you start at row 0 is my point. Let's highlight the row 0. Let's highlight the row 0, right? It only makes sense if the row is 0 there. Let's keep going. This is row 7. This is row 8, and that will continue. And watch this. I'm going to highlight some of the important things here. I'm going to highlight, look, this row 1 corresponds to this guy here, right? Because there's no, well, you'll see the pattern later. Row 2 here corresponds to this number. Row 3 here corresponds to these numbers. Row 4 corresponds to these numbers. Row 5, which corresponds to these numbers. Oh my God, row 6. I mean, you don't have to notice all these patterns just yet, but recognizing them is kind of fun. Row 7, and recognizing patterns is a really fun thing, and it's also really healthy for math. Do you see all these cool things that we just created? Oh my God. So it's all ones, right, along the side, right, to build this triangle. And it's like the 2, 3, 4, 5, 6, with the row that it's at is actually in the middle kind of somewhere, right? In the middle, or right next to the ones is the best way to describe it probably. Is that what you were thinking in your head? I hope so, and I know you did, okay? All right, now what we're gonna do now is, let's actually write some more things, okay? How are you getting these values, right? How about this number? Okay, I think if you were able to get the pattern, you obviously got that this, I'm gonna erase this one just because it doesn't look quite as nice as that right there. I think you know what I'm talking about, okay? So how did you get this 3? You got 3 because you probably added these two numbers above. So you were summing the numbers right above to the sides of it, right? And then you were also the 3 is a sum of these two numbers here. That means, well, if your theory works, that means this 4 is a sum of the two top numbers here. And this 6 is also a sum of the two top numbers above it. And this 4 is also a sum of the numbers above it. Okay? Well, then how about the 5 that you got? Well, does your theory work for the 10? The 10? The 5? Yes? Yes? How about the 6? The 15? The 20? The 15? The 6? Does it all work with your theory? Then you'd be great. Exactly. Even this 2 right here, it's actually, what's another shape that I didn't forget? Oh, let's go to a backward triangle. Isn't that the sum of that one? And you're right, this 1 is a 1 because it had nothing to sum up. And this theory works. That's a pattern of Pascal's triangle. Now, let's see what else I have to mention about the Pascal's triangle. Now, this Pascal's triangle can be formed by you because you know how it works now. And there's a beautiful pattern within it, right? Maybe you're familiar with it, but maybe you can also see how it's related to this here, which is the binomial theorem. Dun, 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 dun. You learned this when you were a baby. Okay, this is the binomial. This is the binomial. And you learned when you were a baby in algebra class, maybe, when you were my size, that you multiply these out, right? You're like, oh, x plus y. Maybe I'll do this one right here. Okay, you could expand this too. Oh, I think you use something called FOIL. I just call it distribution property. Okay, you go xy plus y squared equals x squared plus 2xy plus y squared. But now, wait. I want you to focus on the actual coefficients here. Oh, actually, I don't like that. The coefficients, okay? I'm just going to highlight it with the underline. Coefficients. Obviously, if there's nothing right in front of a variable, you know it's a 1 and a 1. Wait. 1, 2, 1. Dun, 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 dun! Do you notice that it's actually this guy here? N equals 2. Wait. Let's write all the patterns here. This 2 here, right, is this 2 here. This 2 here, maybe it's this 2 here. I don't know. I'm just saying for now, right? The actual coefficients of this binomial, when expanded, I'm using all the vocabulary that you'll be utilizing this semester, or this unit, okay? This 2, when expanded, it provides you with the binomial from the Pascal's triangle, the coefficients of the Pascal's triangle is providing you with the coefficients of this expanded form. And guess what? They're directly related. So this is row 3. Remember that? This is row 3. So you look at row 3. Right? If this guy's a 1, you look at row 2 of Pascal's triangle. Look at row 3. And of course, I know that you came up with these patterns already. This one, look at row 1, right? Which is 0. Okay? So which row would you look at here? Look at row 4, because you're looking at this exponent here. Now, I know if you're like me, do you really like expanding x plus y to the 5th power? That means you go x plus 5 x plus y, 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 x plus y 5 times. That would take forever. Dun, 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 dun. But not if you know the binomial theorem and the actual Pascal's triangle. And that's the power of Pascal's triangle. Dun, 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 dun. If you don't remember, if you're too lazy to expand all this, you can just quickly do a little jot down of the Pascal's triangle to get the coefficient, but I'm going to also teach you another method, of course. Now, before we move on to the next thing, we're going to write that this guy is your n equals 0. Okay, the row that we're looking at. N equals 1, n equals 2, n equals 3, n equals 4, n equals 5. And this is the row 1, row 2. But I'll write this on the side here, row 1. I write it so ugly, sorry. You should write that, you should remind yourself that this is actually row, oh my gosh, row 1. So I'll write it on the side. Let's write it in like a little, let's write it in a little red. No, I don't want to do that. Let's write it in brown, okay? Row 1. This is row 2. Okay? So just keep that pattern. Row 3. Like look at the what I wrote to look at continues, okay? All right. Now, on the next video, I'll explain what and how to use this, including some calculator tricks. So have your calculator handy now.